Now this question here, you have two events. So a fair die is thrown once and random variable x denotes the score obtained. Right now, expectation of E, variance of x. Okay, that's pretty okay. The die is shown twice, but I think the first part should be quite fast. If it's just one, it should be quite fast. A fair die, quite fast, right? Just the first one is like that. 1, 2, 3, 4, 5, 6. Then what you need is just x because this is fair. Very fair one. 2, 3, 4, 5, 6. Okay. Then that's about it. You just 1, 6 throughout. 1, 6, 1, 6, 1, 6. Fair, right? Yeah. Then the expectation is pretty okay lah. Expectation should be just 3.5. Okay, just write 3.5 because if it's fair, it has and it's symmetrical 1, 2, 3, 4, 5, 6. You can tell straight away that the what do you call it? The expectation should be half of it. So expectation of x will be 1 times 1 over 6 plus 2 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6. Okay, this will just be 3.5. Then you ask to show that variance x is 35 over 12. I think that's pretty okay lah. Okay, this is x squared. Yeah, it's fine. This one is like quite okay. That would be 96 over 6. 91 over 6. Variance x. Actually, should be quite fast. What I'm interested is the second one. The die is thrown twice. X1 and X2 obtained for each attempt. Tabulate the probability distribution of this one and find EY. Okay. Now, this X1 and X2 just means independent observation. It doesn't matter. It can be two separate die, or it can be one die throw twice. So two independent observation. Now you need this one, mod x minus x2. The best way to see this thing is use the probability diagram because you have two die. Now, typically two die just use probability diagram. So this is what you do. You list out all the cases down by using the probability diagram. So one, this is, I think secondary school done this before. 1, 2, 3, 4, 5, and 6. Then you do the same thing. 1, 2, 3, 4, 5, 6. Okay, this is a probability diagram. I'm just going to list all the outcomes that I have here. So this case here, I got, this is like x1 and x2. Okay, so you just list down. The first trial will be 1, 2, 3, 4, 5, 6. Is 1, 2, 3, 4, 5, 6. Okay, then you just, these are the header rows. So just label like that. Okay. So I will say you list the outcome. This is the easiest way to do it. So because this, you list the outcome, this means x1 minus x2 modulus, you mod the difference. Okay. you take x1, you minus x2, you take the mod, meaning you take the difference, positive difference. So what I'm saying is this whole thing here, list down all your data point of mod x1 minus x2 here. Okay, we try and understand. So I'm listing all the, it's just like a tree diagram, but instead of a tree diagram, we use a probability diagram because it will show all the different cases and all the different points. Okay, so this one actually lists all the things out. You list all the probable events out. Okay, so then what you do here is very quite quick one. X1 minus x2 is 0. So this is 1. This is 3 minus 1 will be 2. 4 minus 1 is 3. 5 minus 1 is 4, 5, and so on. Okay. So 1 minus 2, this is 1. Then you realize that actually it's just like that. Just quite nicely done for you. 6. Sorry. 6 minus 2. Am I right? No, I'm wrong. Oh, I'm so wrong. 2 minus 2 is 0. Okay. Yeah, I'm wrong. So this one is see then this will be 2 minus 2 is 0. 2, 3, this is 2. Oh, it's symmetrical about here. And it's symmetrical about here. Yeah. This is more like it. And 3, 3, 3, 4, 4, 5. 3, 3, 4. Okay. So these are all the cases I have. You sit down. Then what to do next? Then we try to understand the question here. Yes. You need paper to write, is it? Yeah, I have. Now you need to ask yourself, what are the chances? Okay, what are the chances of one of these blocks happening? Now you have 36 squares in total, right? 36. Okay, but you cannot just assume there is 1 over 36 for each one because sometimes the weightage is different. So what I mean is this is a fair die, so the weightage is the same. Sometimes the weightage here is different. So this is 1/6. These are all 1/6 chance. These are all 1/6 chance. Just bear in mind. So the way you read it is like that. These are all 1/6 chances. So to get this probability here, you need to take this multiply with this. Okay. So just make sure you multiply properly the chances properly. Okay. So because sometimes the weightage will be different, but this case here is easy because it's just 1/6 throughout, 1 over 36 throughout. Okay. I think that's about it. So EY. So you tabulate EY. So now you have all the cases here already. What you do is you just tabulate EY 1 0 1 2 3 4 5 1 1 2 3 4. Now remember that discrete random probability is exhaustive. You need to list out everything. So this is Y 0 1 2 3 4 5. Is here 5. Then PY equals to Y. Okay. So then you ask yourself, what are the chances of getting 0? 1, 2. Chances of getting 0 would be 1, 2, 3, 4, 5, 6. 6 out of 36. Okay. Getting 1 will be 8. 10 out. Getting 2 will be, just count the number of 1 you have, 2 you have 8 out of 36. 3 you have 6 out of 36. 4 you have 4 out of 36. There will be 2 out of 36. Okay. Yeah. So I do this one. Question. So EY, expectation of Y weighted average. Huh? But let's look at part 1 and 2. Explain reason. So the random variable x z is defined as you take the first observation minus the second observation, but you don't mod it. Okay, the second one you mod it lah. So what I'm saying is essentially the first one is, can you imagine that now that if you take x1 minus x2 without modulus it, right? Meaning all these here would be negative. Get it? All these will be negative. This side here. Because all these are x1 smaller than x2. So this side here, all this portion here will be negative number instead of positive one. That's about it. So means for your z distribution, right, you have from -5 to 5. Okay, just that the chances are being split. So this one will half. So I can quickly draw this out. For z, right, distribution, right, if you really understand what's going on, this will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. So this case here, this is z, this is p, z equals to z. So this is -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. By understanding my z, I know that the chances here will be 6 over 36. Okay. For the 1, it will be 5 instead of 10 because it will be divided over here, half of it. Then that will be 4, 3, 2, 1. 4, 3, 2, 1. Is that okay? So just by looking at the equation, I'll get to understand what's going on. But you don't really need to write down the diagram down. Okay, you can just I'm just speaking out loud what I'm thinking and how I'm approaching the question. Very quickly can tell is like that. Okay, is that all right? So without the mod, you will stretch all the way -5, and you just split half of the positive one over the negative side. It's just by looking at this diagram here. Okay, now, so for the first part, stay with a reason whether or not ez squared equals to ey squared. So, is it the same? So z square will be x1 minus x1 minus x2 square, right? Right. And also, you know that this will give you x1 minus modulus x1 minus x2 square. Is that okay? It's just basically x square equals to mod x square. When this is square, you can just mod it. So in other words, this is just y square. So z square equals to y square. Hence, expectation of z square equals to expectation of y square. Okay, this one is very straightforward because if you were to square it, if you were to square this, right, this and this, right, they will have the same probability distribution table, the same, exactly the same. Okay, so this is the first one. Actually, you can just write it like that. So it's the first part. It's just it's just algebra. And part 2, variance z and variance y, is it the same? No, right? Do you see the distribution table is different? Okay, so the spread will be different. So why is the same one? No, you don't times twice the probability. It'll be the same. You see, it'll be the same. So let me show you how it becomes. Z squared, this will be 25, right? This is also 25, right? This is 16, this is 9, this is 2, this is 101, 2, 9, 16, right? It will be the same. So z squared would actually be 0, 1, 2, 9, 16, and 25. And essentially the probability of z squared equals to z squared. 0 will be 6 over 36. 1 will be this plus this one. Then this will be this plus this one. This, then it will be the same as the y square. Okay, is that okay? So it's the same because when you square it, you need to merge the probability up. Okay, if you want to know what's going on back end, this is z square. Part two, part two, but square never merge. But y square, oh, because you square it is the same. It's if you take y square, this is 0, this is 1, this is 4, this is 9, 16, and 25. Is the reason why you merge is because these are same data point, 25. If it y square only merge because you don't have any same one. If you have same one, then you need to merge. But for z square, you need to merge. Yeah. Okay. That's it. Part two. Part two will be okay, so for part two, variance z and variance y. Okay. Variance z and variance y, you will get different, right? Is variance z equals to variance y? How do you show? Okay, here. So should be lesser p than z squared, I thought. Hey, you don't square the probability. Like since y squared never merge, it should be lesser than the z squared, I thought. Huh? No. The z squared, it was being split, right? This is, you see, this is 6 over 36. Then this is 3 over 36, right? So it's 3 over 36 here, right? If you add both of them up, isn't it 6 over 36 is the same? Because just now this one was split into half. Okay. So now this one here, is it the same? Okay, actually you can just write down this one. So the question now is it the same? So you just break down variance z is equals to expectation of z square minus expectation of z square. Okay. Then variance y is expectation of y square equals minus of expectation of y square, like that. This is one of the way. If you do not want to use this method, you can use other method. Like you just calculate it brute force. So variance z, okay, we know that ez square is equals to ey square. No question asked. Okay, this is the same. But ez is not equals to ey. Okay. Expectation of z will be what? Expectation of z will be, you want to give a guess? What's expectation of z? Expectation of z is equals to 0. Confirm 0, 1. Why? Because it's centered about 0. Right? It's the negative one would nullify each other on the other end, and negative 2 nullify negative 2, and so on. So easy confirm is 0, 1. So hence, variance z is not equals to variance y. This is one way you can write it out. Okay, so what I did was I just say variance z is this formula, variance y is this formula. So although these two are the same value, we know that z squared equals to y squared, but ez not equals to ey since yeah. So part 2. Any question? Ask now. Please ask. Keep asking. Okay. So